Are humans and our fellow travelers on Earth latecomers to the game of life? The idea of truly ancient first civilizations is a staple in science fiction. But when was the earliest moment in the 13.7 billion year history of the cosmos when life as we know it could have first formed? That was the unlikely question that came to Harvard astrophysicist Avi Loeb as he and his family prepared for their Thanksgiving celebration. The answer, as he said, represents the quintessence of at least one form of creativity in science. The idea came to me in the shower on Thanksgiving morning while thinking about the earliest cosmic time when stars may have formed in the early universe, tens of millions of years after the Big Bang. I realized that around that time, the cosmic microwave background had roughly room temperature, which is convenient for life. The cosmic microwave background, or CMB, is a bath of radiation left over from just after the Big Bang. It emerges just 300,000 years after the moment of creation, which, in the grand scheme of things, is the blink of an eye. The CMB is a kind of glowing electromagnetic fossil that pervades the cosmos. It's everywhere in space and has been cooling as the universe expands. After 13.7 billion years, the CMB now has a temperature of just 2.7 degrees above absolute zero. That's cold, but when the CMB was first created, it had a temperature of a few thousand degrees, which is what you find on the surface of some giant stars. What Loeb realized was that in between then and now, there must have been a period when the entire universe was essentially just warm enough to allow even planets far from their stars to have liquid water on their surfaces. His paper pointed out that when the universe was 15 million years old, the cosmic microwave background had the temperature of a warm summer day on Earth. If rocky planets existed in that era, then the CMB could have kept their surfaces warm, even if they did not reside in the habitable zone around their parent star. Hence, liquid water could have existed on their surface, starting the chemistry of life as we know it. Since the basic scientific definition of habitability depends on surface water, what Loeb had discovered was an early epoch of universal cosmic habitability, a very exciting idea indeed. The implications for Loeb's result are huge. First of all, it shows that life could have started in the universe 10 billion years before it started on Earth. The universe, as he puts it, may be full of life, and we are latecomers. By demonstrating that life could have formed so early, Loeb may have even delivered a blow to so-called anthropic arguments about life in the universe. What's most interesting about Loeb's insight, however, is that it clearly represents one very particular kind of creative act in science. Avi Loeb saw something that had always been there. Every physicist knows that the temperature of the universe drops as it ages. It's the kind of thing you can find in undergraduate textbooks, but no one had ever connected that fact to the question of life and habitability before. No one had seen what Loeb saw staring him in the face. It is indeed very surprising that this paper was not written a long time ago. I usually seek paths that were never explored, but often find footprints of earlier travelers on those. Here, the path was relatively clean, and when that happens, it is truly a thing of beauty. Now, here's what I think. If it only took 15 million years for the universe to go from being a few thousand degrees to being just as warm as a summer day on Earth, imagine how fast the temperature would have dropped to unbearably cold after that. So even if life did start developing at that point, I doubt it would have had enough of a window to evolve into complex life forms before it was stopped in its tracks by the ever-declining temperature of the universe. What do you think? Let us know in the comments. Thanks for watching.